Hey guys, we're back with the notes for 5.7. Today we're going to be writing systems from word problems. We're not going to be doing any solving, there's why there's no space, but we're just going to be setting up the equations, okay? Once we get to 5.8, you're going to see the same questions come back, and that is when we'll worry about solving for the actual answers, okay? So on these notes, we're going to break them into 4 categories. For each category, I'm going to give you about 4 or 5 questions to work on. And once we're through those, what I would encourage you to do is pause, try the practice problems that match that type, then come back and go back to the notes, okay? All right, so let's talk about the first type of problems, and that's problems with coins. When it comes down to coins, you have 2 different scenarios. You have the amount of coins, which is like how many actual coins you have. So maybe 3 or 4 nickels, 5 or 6 dimes. That is the amount, how many coins. When it comes to the dollar amount, that's the worth. When you are talking about the total worth, you are going to have to talk about how much each coin's value is. So instead of just saying the dimes, there's 3 of them, now we actually have to put 0.10 dimes. We actually have to say that each of those dimes is worth 10 cents. Let's go through the first problem so you can see what I mean. Sam has 30 nickels and dimes. That's total, not 30 each, 30 total. So we're going to use N for nickels, D for dimes. The nickels plus the dimes makes 30. Okay? I'm going to jump around just a little bit. If I look on problem 2, I'll notice a very similar question. It says Kelly has 24 dimes and quarters. That means that there is a total between the dimes and the quarters. There is a total of 24 coins. Okay? So total amount is not having to do with anything for the money value. It's just counting the items. When we talk about the worth, we know that the total worth is $2.40. Well, if that's going to be money, I have to know how much each thing is worth. So my nickels, those are 10 cents each. So 0.10 N. My dimes, oops, sorry, I totally did that wrong, sorry. 0.05, 5 cents for the nickels. For my dimes, that's where I'm going to do 0.10, 10 cents for each dime. Sorry, I didn't mean to confuse you. Okay, that is my second equation. That is telling me the worth of the coins. Okay, let's do the same thing for number 2. For number 2, it says that 24 dimes and quarters are worth $3.60. So the dimes are going to be worth 10 cents. The quarters are going to be worth 25 cents each. And now, all together, that makes $3.60. So notice, if I use the decimal on the money, I have to have a decimal for money on everything. If I'm using just the coins, there's no dollar signs, there's no decimals. That's when I just use the plain letters. Okay? All right, so on number 3, it says Lee has $4.80 in dimes and quarters. That's the worth, right? That's money value. So I'm going to keep my dimes and quarters. 0.10 for dimes, 10 cents each. 0.25 for quarters, 25 cents each. Total of $4.80. Okay? When it comes to the other one, I don't have a total. I can't just do D plus Q. What I use is kind of this little teeter-tot method. It says he has 6 more dimes than quarters. So he definitely has more dimes. I'm going to put that on the bottom because it's going to be heavier. I have more dimes than quarters, so it tilts the teeter-totter. If I want it to balance, I have to put something else with the Q in order to balance it out. So if it says I have 6 more than quarters, I'm going to add 6. So now it would be balanced. My equation, dimes are 6 more than quarters. Okay? All right, let's try another question like that. Ben has $3.40 in nickels and dimes. So the nickels are worth 5 cents. Notice I'm using 0.05 and not 0.5. That would be 50 cents. 5 cents for nickels, 10 cents for dimes, and it's worth a total of $3.40. That's the worth. When it comes to the total, I don't have it, but I do have a comparison. It says he has 4 more dimes than nickels. So dimes are more, nickels are less. In order to balance it out, I have to put more with the nickels. And to be specific, I need 4 more. Now they're balanced, and I have my equation. D equals nickels plus 4. It doesn't really matter if you do 6 plus q or q plus 6. It doesn't really matter if you do n plus 4 or 4 plus n. Doesn't matter. It's the same thing. Okay? All right, number 5, last one. It says Nancy and Carrie have the same number of coins. Nancy has only dimes. Carrie has only quarters, but they have the same amount. So in their hands, the dime amount and the quarter amount are exactly equal. So maybe I have 10 of each, 10 dimes and 10 quarters, or 3 dimes, 3 quarters. We don't know yet, but I have the same amount of each. Now, when it comes for the worth, and I see that $3, now I have to start putting the decimals with it. So it says Carrie has $3 more than Nancy. Well, if they're the exact same coins, what does Carrie have? Carrie has quarters. So the quarter amount is $3 more than Nancy's dime amount. But remember, what has to be in front of them if I'm talking about their worth? Well, I have to put their value, 0.25 quarters. The worth of the quarters is $3 more than the worth of the dimes. Okay? All right, what I would do is pause it. Try doing page, I think it's 172. Let's see. That's where we are now. So 174. I would try doing page 174, the first 4 questions. Those are your coin problems. Okay? Then come back. All right, if you're back, that means you're ready to talk about total and compare problems. When it comes to total and compare problems, we've already talked about a total. Total means that you're going to add up the 2 pieces and make it equal the total amount. When it comes to a comparison, that's where we're going to use the teeter-totter, and we're going to start with whoever has the most. So let's go ahead and try number 6. It says a television station received 18,717 calls from its viewers in response to a new TV show. There were 893 fewer calls disliking the show as those that are liking the show. So in this situation, we have 2 kinds of calls. We have dislikes and likes. Together, there were a total of 18,717 phone calls. Once I'm ready to do my comparison, what I would suggest is you draw a teeter-totter. On my teeter-totter, what did I get more of? Well, there were fewer calls disliking than those liking. So there were more likes. If I want to balance the scale, I need to put something else with the D. I can't subtract because that would make it lighter. So I'm going to add. The dislikes plus 893 would make that balance. So my equation is L equals D plus 893. There are 893 fewer of the dislikes. Okay. All right, let's try the next one. Next problem says Brandy and Mark, those are my variables, are selling magazines. Brandy has sold half as many as Mark. Okay. So Brandy didn't sell very many. She's up here light. Brandy sold half as many as Mark. So Mark's really heavy. I have to put something with Brandy to level her out. So hers is half of Mark's. That means 2 of Brandy's would equal 1 whole Mark. That's my first equation. Mark is twice as much as Brandy. All right. Last part of my equation that I'm going to need. Whoops. Sorry, that was technically supposed to be in orange. Give me just a second. There we go. My second equation is going to be my total. Together, they sold a total of $4.74. I can't even talk, sorry. Together, they sold 474 magazines. So we're going to put them together. Brandy plus Mark equals 474. Okay, those are your 2 equations. You have your comparison and you have your total. We're going to do one more of these down on problem 8. It's actually on the next page. Okay, this one says Ann and Betty together have $60. So Ann plus Betty equals $60. For the comparison, it says Ann has 9 more than twice Betty. So Ann has more, Betty has less. We need to do 9 more than twice Betty. So we're not only going to add 9, we're actually going to double it first. So 2 times Brandy and then plus 9. If you put the 9 before it and you do 9 plus 2B, That's exactly the same thing. It is not wrong, okay? But I'm going to go ahead and write A equals 2B plus 9. 9 more than twice Betty's amount, okay? All right, if I were you, here's what I would do. I would pause on the screen, go through and try on page 174, try problems 5, 6, 7, and 8. Those are this kind of problem. When you're done, come back and we'll hit the type 3, okay? All right, if you're back, that means you are ready for the third kind, and our third kind is called perimeter problems. Now, back in Unit 1, you made a vow. You said, I will never write P equals. And that's because P isn't a variable. Perimeter is a formula. So every time you see perimeter, you're going to go back and use that 2W plus 2L equals your total for the perimeter. So if I look on problem 9, I already see that the perimeter, 2W plus 2L, is 130. I can do the exact same thing on number 10. I already see that the perimeter, 2W plus 2L, is a total of 80. The only thing I'm missing is my comparison. So let's make a teeter-totter. All right, so on problem 9, it says the length of a rectangle is 5 more than twice the width. Well, we just knew how to do 9 more than twice Betty, so let's do the same thing. The length is more than the width, so the width is up high. In order to balance it out, I have to put more with it. So I'm going to do twice the width and then 5 more than that. My equation is L equals 2W plus 5. Okay. Last one of these, problem 10. The length is 4 more than the width, or 4 centimeters longer than the width. That means the L is more, the W is less, it's up high. To balance it out, I need to put 4 longer, or plus 4. My equation is L equals W plus 4. Okay. All right, I would go ahead, flip back. You're going to be on page 175 now. There's only one perimeter question, so go ahead and try number 9. When you're done, come back and we'll go over the last kind of problem. Perfect. If you're back, it means you're ready for the last type of problem. Those are called matchup problems. You're going to have 2 different scenarios, both with numbers and the variables the same. So it's not 2 different kinds, it's 2 of the same kind. Okay, your problems are going to look like number with your variable equals the first total. You're going to do the same thing. New number with your variable, new number with your variable, and a total second. Okay, let's go through this one. I'm going to highlight them in different colors. Your first problem is going to come out of this first sentence. Judy worked 8 hours, Ben worked 10 hours. Their combined pay was $80. So I'm going to partner up the variables. 8 goes with Judy, 10 goes with Ben, total of $85. $80, sorry, I'm losing my mind. 8 goes with Judy, 10 goes with Ben, 80 is the total. If I look at the second equation though, we're going to go Judy worked 9 hours, so 9 goes with Judy. Ben worked 5 hours, so 5 goes with Ben. And the total was 65. Notice those equations look almost identical. They just have different partner numbers and different totals. They're set up the same. Okay, let's try the next problem. Here's what I would do. I am really bad at making S's for variables because they look like 5s. And I'm really bad at making O's for variables because they look like 0s. So I'm going to use X and Y for this next problem. Okay, all right. First sentence, the cost of 5 squash and 2 onions is $1.32. So I'm going to do 5x, 2y equals $1.32. For the second equation, 3 squash and 1 onion is 75 cents. So 3x and 1y equals 75 cents. That's all you're doing for those. Okay, you're just matching up the pieces. All right. Last one, a movie theater charges $5 for adult tickets and $2 for a child's ticket. One Saturday, the theater sold 785 tickets for $3,280. Okay, this one's a little tricky because in the pink, I'm dealing with money, right? $5, $2. So 5 adult, 2 child, sold for a total of $3,280. These are all dollars. You don't have to put the dollar sign, but that's your units, okay? The part that you can't see is what you're doing here. They sold a total of 785 tickets. Well, you already know what the tickets are. The tickets are A and C, adult tickets and child tickets. The total is 785. So this part is your tickets. The first part we did was where your money was. And that's why we don't really need the dollar signs on there. Okay? All right, once you get to this problem, you should be able to finish all the way, I think, number 10 to 14. You do have 18 questions, so make sure that you do the multiple choice on the back, but you should be ready to get started. If you have any questions, please come see me.